Okay, it's all right. It's just gonna start over. Okay, so I got the timeline here. So this is all laid out. This is a good comparison of different historic mortality shocks. And all the historic events I've got stars next to. And the deaths from COVID I've got circles. Okay, and then the corresponding multiples are boxed next to these. So we're going to go through these and look. And these are all things that made the news. These were big headlines when they happened. Back in 2016 in August, the peak of the Chicago homicide murder wave, okay, in August of 2016, it only barely increased the normal death rate for the city of Chicago. So the multiple was 1.01. It's almost identical. Barely made a blip. Okay? But it's a lot of times it's the way people die that gets our attention, right? It's the fact that they were killed with guns and in cold blood in the streets. And it was senseless. All these young people were dying of gun violence. So that was part of it. January of 2011, there was a bad flu in New York City, 1.05, okay? In January of that year. That month we barely saw an increase. A little bit more of an increase. The peak month of the AIDS epidemic in New York City, which was the epicenter of the AIDS epidemic, in September of 95, 1.15 was the multiple, okay? Up from normal, 1.15 times normal. Here's our first COVID count for Oslo, Norway, which was what we were talking about, the difference between Oslo and Stockholm. Oslo, Norway had a pretty modest, moderate, not too bad outbreak of COVID. 1.16 was their multiple. Okay. To give you a comparison, at 1.61, substantially higher, but I had to squeeze all these in so it's not really to scale on this from 1 to 2. You see New York City, September 11th, 3,000 people died, remember? That was 1.61 times when it added to the overall total of everybody dying of heart attacks, cancer, everything. It was 1.61 times their normal mortality, okay? But look, Moscow during COVID has had more mortality than New York City did, more of a jump in mortality, more of a severe mortality spike than September 11th. Paris heat wave was really bad, 2, double their normal mortality, okay? But here, look, here's 2 COVIDs. Stockholm and Boston had a higher mortality from COVID than the Paris heat wave. And it was on a par with Katrina. Remember Hurricane Katrina, New Orleans?
Yeah.
2.42. Paris has had a more severe mortality spike from COVID than New Orleans had for Katrina. London, triple the mortality. Okay? You guys have heard of the Spanish flu, right?
Yeah.
That was one of the most severe, probably the most deadly pandemics in history. Okay? There's estimates as high as 100 million people around the world died of the Spanish flu. And in Boston, it was over 3.5 times the normal mortality in October of 2018.
But then
It's October of 1918.
Did they do like quarantine with that?
Oh yeah, they tried, and certain cities did more than others. We're gonna get over here to Philadelphia, who had the worst outbreak in the U.S. of Spanish flu. St. Louis did. Philadelphia had hardly any quarantine and had big parades and things like that in the streets, and it led to the spread. St. Louis canceled all that stuff, closed the schools, and they had a much lower outbreak much less transmission.
But then, like,
But see, here the cities for Spanish flu, we can just look. Boston, 3.5 times. New York City, almost 4 times the normal mortality. Philadelphia, over 7 times the normal mortality. This is something you don't see except in times of war. This is really bad.
Yeah.
Look here, Lima for COVID was 3.99, almost 4 times the normal mortality. That's a very bad outbreak. And then look at all these COVID statistics. Madrid, Gaius, Ecuador, New York City, 4.5, 5.5, almost 6 times the normal mortality. New York City had a very bad
and then
outbreak.
Italy is
Bergamo, Italy.
more than 6.5 times.
Right. The worst local outbreak in a city so far has been Bergamo, Italy, in northern Italy. 6.67. But New York City is not much better, and New York's a way bigger city, so imagine the numbers, you know. The numbers,
Probably more.
more people die in a normal year in New York City by far than Bergamo. And so the numbers in pure terms are just massive. When almost 6 times the people die, when almost 6 times the normal number of people die, it's in a city as big as New York, that amounts to a huge number, okay? So, but look at all this, look at how bad these numbers are for COVID compared to these historic events.
The only worst thing that's on the board is the Spanish flu.
In Philly.
Yeah. Because they didn't do.
They didn't even do any mitigation, really. Yeah.
It was just.
So, I wanted to show you this. I thought it was a good way to visualize the relative, magnitude of these mortality shocks, the relative severity of these mortality shocks. And severity is relative itself, right? Because severity is measured against what your normal is. If you live in a tiny town like Clifton, maybe only 10 people, maybe 5 people die a month on average. I don't know. I mean, it's not a lot of people in a town that size. In New York City, it could be several thousand die every month. I don't know what the death rate is, but it's relative to the population. Obviously, it's like so many people per 1,000 population. And so the severity is relative, 100 people dying in New York is not as severe as 100 people dying in Clifton, right? Because it's relative to their population. So anyway, that is something else to take into account. These aren't pure numbers, these are relative to their normal death rates. Okay, so that's good. We're gonna erase all this. I just wanted to show you all that, and then I'm gonna show you something from my math notebook. Oh, I've got 3 minutes. Okay.
It's only gonna be a short lesson. Nothing.
It is gonna be a short lesson. Hold on.
You said there's only 3 minutes. That's
Yeah, it is. It is. So I wanted to just introduce you to some geometry. I'm gonna show you this stuff. So this is very ancient geometry. It's kind of neat ways to find equivalences and neat ways to visualize how shapes or neat ways to visualize certain things. I'm going to show you. Hold on. Okay. And this is it's called Euclidean geometry because it was discovered by an ancient Greek guy named Euclid. Euclidean geometry. And this is stuff you can discover just by drawing in the sand. I mean, this is you don't need any fancy.
okay.
2 minutes.
Wait, on the timer?
Yeah.
How
1
was that
minute.
a short lesson?
So one of the things that he was looking at was you've got this angle here, right? And you want to bisect it perfectly. And you want to figure out where is the line between here and there that bisects this and splits this angle in half perfectly. And Euclid discovered that if you drew a circle that intersected here and another circle that intersected here, I'm gonna have to look into this a little more. I didn't write enough down to talk about it. I want to show you this though.
Less than 30 seconds.
Now, this is a right triangle.
Yeah.
Sides, this is a 1, and then a squared plus b squared equals c squared. So